Okay, welcome back everyone. This is the Delta Workbook. It's Mr. Australia here with lesson 2. And today we're converting recurring decimals to fractions, the opposite of what we were doing in our last lesson, lesson 1. If you haven't had a go already, pause the video and have a go at the do it now questions. Okay, for the first one here, we've got addition. We're going to start with our largest number on top. So we've got 10,874. And then we've got 5,647. Just make sure that everything is nice and in line in its columns. And then we're ready to get adding. 4 add 7 will give you 11, carry the 1. Then you've got 12, carry the 1. Then we've got 15, carry the 1. 6, and then 1 add nothing will be 1 still. Okay, so we've got 16,521. Okay, next we've got fractions, but this time we are multiplying. Now, when we're multiplying fractions, what we need to do is multiply our numerators and then multiply our denominators. It's also called cross multiplication. So you're going to multiply your numerators 2 times 1, that gives you 2, and then our denominators 3 times 4, that gives us 12. But we won't write our answer as 2/12 because that is not in its simplest form. We need to simplify, and both of these are in the 2 times table, so we can divide them both by 2, and we will get 1/6, 1/6. Okay, well, now we've got division. So we've got 4760 divided by 8. So we're going to use the bus stop method again. We've got 47 pounds 60. And we're dividing that by 8. Put my decimal point in here. We now need to think how many 8s fit into 4. We cannot fit any, so we join those up. We've now got 47. 8 times what gives us 47? Well, 8 times 5 gets us close to 40, and we've got a remainder of 7. 8 times what gives me 76? Well, 8 times 9 gives me 72, so my remainder is 4. I've now got how many 8s go into 40? 5. That goes exactly. We found a monetary amount and it's in pounds, so we need to include those units, and it's £5.95. Okay, next we're expanding the bracket. When you're expanding a bracket, you need to multiply the terms on the inside of the bracket by the term on the outside of the bracket. First, we've got 5 times 3x. That will give us 15x. Next, we've got 5 multiplied by -2. Well, 5 times +2 is 10, so 5 times -2 will be -10. Next, 45% as a fraction in its lowest form. Well, 45% literally means 45 out of 100. But these numbers have a 5 and a 0 on the end of them, so that guarantees them to be in the 5 times table. So we can simplify by dividing both by 5. 45 divided by 5 gives me 9. 100 divided by 5 gives me 20. You can think about 10 divided by 5 giving me 2, so 100 divided by 5 will give you 20. We cannot simplify this any further, so that's going to be our final answer, 9/20. Okay, next, the highest common factor of 35 and 63. With low numbers like this, it's what is the highest times table that both 35 and 63 are in. The highest times table will be the highest factor, okay? And that's going to be 7 here. 7 times 5 gives you 35, 7 times 9 gives you 63. So 7 is the highest common factor of these two values. Okay, we're going to look at some of the examples now. So I'm just going to rub some of these out and we'll zoom down. Okay. So what we're doing today is we're going from a recurring decimal to a fraction, and we're going to use something called simultaneous equations to help us here. Simultaneous means very similar to what it means when you use it in the real world. It means two things that are coinciding that are both true. They're both happening at the same time. Okay. The example that they've done here is converting 0.3 recurring into a fraction. So what they've done is they've just written out the first few decimal values. So I'll just highlight that here. 0.33333. That will go on for infinity. Now, what we want to do is we want to remove the recurring decimal part. So we've used our placeholders to help us. Now, they've called this 1n. They said that that is equal to 1n. And then if we multiply all of this by 10, the digits will not change at all. The only thing that's going to change there is the placeholder. And you can now see that the new decimal point, not 0.3 recurring, it's 3.3 recurring. And it looks a bit clearer if you write these things above each other. I'm just going to call this x, and I'm going to say x was equal to my original fraction, 0.3 recurring. Okay. And then if I multiply that by 10, so 10x, your placeholder is going to move one position, and it's now going to be 3.3. Now, hopefully you can see that the numbers after the decimal point, they now match up. So if I call this equation 1 and this equation 2, what happens when I do equation 2 subtract equation 1? Well, let's think about the x's first. If we've got 10x take away 1x, that leaves us with 9x. Okay. Now we're subtracting line number 2, equation number 2, from equation number 1. So you've got 3.3 recurring, take away 0.3 recurring. These are going to cancel out. You've then got 3 take away 0, which is just 3. Now, just like with any equation, we want to try and find the term on its own. What is that value equal to? How have you got from 9 to x? You've divided by 9. Because we must keep our equations balanced, you're going to divide the other side by 9 as well. So it's 3 divided by 9. Thinking back to your fractions, 3 divided by 9, you can write using your line here. This is 3 divided by 9. And just like with any fraction, we must always simplify our answer when possible. Both 3 and 9 are in the 3 times table, so we can divide them both by 3. And that's why 0.3 recurring is equivalent to 1/3. So that's one example there. I'm going to show you 2 more examples now. Okay, it's still using the same technique. With these examples, you will just have to go a couple of steps further. So we'll do this next one now. Okay, let's think about 0.32 recurring. So 0.32 recurring is just 0.3232 for infinity. Go on and on and on. So we will put 1x is equal to the original, 0.32 recurring, 0.3232, and then we'll see what 10x would look like. Now, it's really helpful here if you can try and keep everything in line. I'm just going to rub these out, actually, to give myself a little bit more space, and you'll see why in just a moment. So that was equal to 0.3232. Okay, if we multiply by 10, decimal is going to jump one position, and everything else will just move along. Now, as you can see, these do not match up. We've got 0.3232, but then in 10x, we've got 0.2323. So that doesn't work. Let's see what happens if we multiply the original x, if we multiply that by 100. Because we're multiplying by 100, it's going to move the placeholder twice, or 2 positions. So we've now got 32.3232. And hopefully you can see now that these actually match up. We've got 323232, 323232. So what we can do here is we can do 100x. So let's label this as, this was say line 3, and this one was line 1. We're now going to do 3 take away 1. In line 3, we had 100x. In line 1, we had 1x. So if you do 100x take away 1x, you'll be left with 99x. If you do 32.3232 recurring take away 0.3232 recurring, you're going to be left with 32 point nothing, just 32. Okay, you now want 1x. To get from 99x to 1x, you've divided by 99. So to keep your equation balanced, you will need to divide the other side by 99 as well. Remembering that the line in your fraction literally means divided by. So this is 32 divided by 99, or 32 99ths. We cannot simplify this fraction any further, so we're going to leave it. That is going to be our final answer. Okay, and that was slightly different because here we have 2 recurring digits, rather in the first example here, when we just had 1 recurring digit. I'm going to show you one more now, and this time we're going to look at a recurring decimal that has 3 recurring digits. Let's see what happens there. It's a very, very similar thing. Some of you might be able to predict what we're going to do next. Let's see what you've come up with. Okay, so the example I'm going to use this time, we'll do this one in red. And we will do, let's do x is equal to 0.5675667. Okay, let's just imagine that's going on and on. So this time our recurring digits are both 5, 6, and 7. They are all recurring. We have 3 recurring digits. Okay, let's see what happens when we get 10x. Keep all of my decimal points. I must keep those in the same position. Okay, if we're multiplying by 10, our placeholder will jump 1 and all the values will move down. So we're going to have this 5.67567. Oh. And as you can see, they don't match up. So that hasn't helped us much there. Let's see what happens when we do 100x. So that's going to be 56.75675. So that hasn't worked either. Let's see what happens when we try 1000x. So we're now multiplying the original value here by 1000. And because you've got 1, 2, 3 zeros on the end there, that placeholder will move, well, the numbers will move along 3 positions. That placeholder will stay in the same position. So we're going to have 567.56757. So we've now got a match. Go back here. It started with 567 after the decimal point and continued on. And that's what we've got here now. So let's imagine this equation here was number 1. And this equation here was number 4. We're now going to do equation 4, take away equation 1. So thinking about the x's first, you had 1000x and you've taken 1x away. So that will leave you with 999 x's. Then if we think about the actual values, we had 567.567567 take away 0.567567. So the values after the decimal point will cancel out. And then you've just got 567 take away nothing. So it's going to be 567. Okay, we now want to go from 999x to just 1x. To do that, we've divided by 999. So you'll need to do the same to this side as well and divide by 999 to keep those equations balanced. Okay, so we'll get 567 over 999. And just like with all fractions, you should always try and simplify. Now, I know this one is not very obvious to you because these are very large numbers of how it would simplify. It can be done, especially when you've got 9s, 99s, 999s. You always want to see if it can be divided by 3 because 999 or 999 will always be able to be divided by 3. So if you do 567 divided by 3, what will you get? You'll get 189. So if we divide both of those by 3, we'll get 199. 999 divided by 3, that's just going to leave us with 333. Let's see what happens if we divide again. 189, would that work if we divide it by 3? Because it's got a 9 on the end. Yes, it will. So if we keep simplifying even further, we would get 63 on top. And then if you divide 333 by 3, you'll get 111. Okay, can we divide any more? Can we divide any more? Well, actually, I've written that down incorrectly. That should be 63. 67. Okay, 63, we know that that's in the 9 times table. We know that that's in the 7 times table. So what are we going to divide by this time? Well, if it's in the 9 times table, there's a good chance that 63 will be in the 3 times table as well. So let's divide that by 3. 63 divided by 3, that will give us 21. And then 111 divided by 3 will give us 37. Okay, so this was a very tricky example to finish on. Okay, but if you want full marks, you must remember just to simplify that answer as much as you can. Okay, so they're the 3 different types of question you might see here in our main questions, and we're going to have a look at those now. If you haven't done so already, just pause the video and have a go at those main questions here. Okay, so looking at question 1, first value we've got for A is 0.5 recurring, 0.5 recurring. Okay. And we can say that that was equal to X. So I'm just going to give myself a little bit more space actually. So we've got 0.5 recurring. So that's 0.5555. And let's say that that was equal to 1X. Now what I want to do is I want to get rid of all of these 5s here after the decimal point. So let's see what happens if I multiply by 10. And multiply by 10, the numbers will move down, the placeholder will stay in the same position. So we've got 5.555, and that works. We now have the exact same thing after the decimal, so we're ready to subtract. If this was equation 1 and this was equation 2, we're now doing equation 2, take away equation 1. 10x take away 1x, that leaves us with 9x. 5.5 recurring, subtract 0.5 recurring, just leaves you with 5. Final thing we need to do now is get from 9x just to 1x. Do that by dividing by 9. And to keep your equation balanced, you must divide the other side by 9. So we've got 5 divided by 9, and your final answer there is just 5/9. And if we think back to our previous lesson, when we had something like 3/9 simplified to a third, that was 0.3 recurring. 7/9, 0.7 recurring. And here we've seen the 0.5 recurring is 5/9. If we look at B, we've actually got 0.1 recurring. So straight away, I can see that that is just going to be 1/9. By all means, do exactly what we did for question 1A over on the right-hand side, and you should still get 1/9. That's just the sort of pattern that you'll start to see here. Next, we're going to have a look at question C. Okay, question C. Just going to actually, we'll do question C down here. Okay, so this is question 1C. Okay, so I'm going to start off with putting 1x is equal to my decimal value, 0.12 recurring. I'll just go on and on and on. And then if I multiply that by 10x, what will we get? Well, we'll get 1.2121, and these do not match up, so that hasn't helped us. Let's try 100x now. Well, 100x will be 12.1212. So this actually works. We now have the values after the decimal point, they're matching up. So we're now ready to subtract our equations. If we say this was equation 1 and this was the third equation, we're now going to do equation 3, take away equation 1. Okay, the values after the decimal will cancel out, so all we're going to be left with there is 100x take away x, that will be 99x, and that's equal to 12. If 99x is equal to 12. How do we get from 99x to 1x? We divide that by 99. So you need to divide 12 by 99 as well to keep your equations balanced. Now I know that 12 is in the 3 times table, and I know 99 will be in the 3 times table because it has all 9s in the number itself. So we can simplify that a bit more. 12 divided by 3 gives us 4. 99 divided by 3 gives us 33. We cannot simplify that any further. So our final answer there will be 4 over 33. That was for question 1C. Just going to, I'll leave C down there just for a minute. You can see how similar it will be to question D. Now, in question D, just like with question C, we had 2 digits that were recurring. So paying attention to especially this part, okay, before we simplified, why don't you see if you can predict what question D is going to be? And we'll have a look and see if your prediction was correct. So we've got 0.363636. Okay, question 1D. So we could say that x was equal to 0.3636 recurring. So 10x, it didn't work the last time when we had 2 digits recurring. And it hasn't worked this time either. They're out of sync. So we'll now try 100. And that's looking better, isn't it? Because 0.363636. We now have these matching. Just highlight those. We now have the same values after our decimal point. What we're going to need to do now is to, was equation 3, this was equation 1. We're now going to do equation 3, take away equation 1. So we've got 100x take away 1x, leaving us with 99x. And then we've got 36.36 recurring, take away 0.36 recurring. So that will just leave us with 36. And to get from 99x to x, you divide by 99. So do you see how it's very similar before we simplified to our previous question? It's very, very similar here. Okay. But like with all fractions, we must simplify when possible. Both of these are in the 9 times table. 36 divided by 9 leaves you with 4. 99 divided by 9 leaves you with 11. Okay, I'll just do that in a different color now. So that's going to be 4/11 once we have simplified. Okay then, E, we've got 0.919191 recurring. See if you can predict what that will be. And then see if it needs to be simplified like we had in question D and question C. Okay, so we're on 1E now. And we've got, let's say, x is equal to 0.9191. Okay. 10x, we know that that's not going to work. It's going to go 9.1919. It's going to have to be 100x because we need, going to have to be 100x. And that will be 91.9191. So it really does help when you're doing this in your workbooks if you can try and keep all of your columns in line, just as if you were doing some column addition. It makes it so much more clearer to see when those values after the decimal are matching up. That's what you need. So this was equation 3, this was equation 1, and we're doing equation 3, take away equation 1. That's going to leave us with 99x, and then the number 91. 99x to 1x, we're dividing by 99. So we've got 91 over 99. We cannot simplify that any further, so we leave that as our final answer. That's 91 over 99. Okay, now for F, it's very, very similar to these questions. So I'm going to leave all of this working out here, and I'm just going to go straight to our answer. If we've got two digits recurring, 0.72, straight away after the decimal point, I know that 99x, that's going to be equal to 72. We'd go through all of the steps that you see here, and you would end up with 99x being equal to 72 rather than 91 this time. You're still going to have to divide by 9. So, sorry, by 99. So that'll be 72 over 99. These are both in the 9 times table, so we can divide them both by 9, and we get 8/11ths, which we cannot simplify any further. So that one there, 8/11ths. Okay. Right, let's have a look at questions G, H, and I. Now these questions, they're slightly different because they have 3 digits that are recurring. And if you haven't done so already, see if you can predict how many lines we're going to need to have for our working out, how many different steps we will take here. Okay, so for G, let's have a look at this one now. We've got 0.125, 125, 125. We'll do this one in green. So we'll put x equal to the original, 0.125, 125, dot, dot, dot. Okay, so let's see what happens when we try 10x. That's not going to work. We've got 1.251. That's out of sync. That doesn't work. Let's try 100x. That would be 12.512. That doesn't work either. Let's go up to 1000x. Points. And there we go, we've got it. We've got that 125, 125, like we had in the original. I'll just highlight that to make it a little bit clearer. So this, and now we've got it here. Okay, so what are we doing this time? Well, this was equation 1, and this was the 4th equation that we tried. So we're now doing equation 4, subtract equation 1. So that's 1000x, subtract 1x, leaving us with 999x. Then we've got 125.125.125, take away 0.125.125, and that will just leave us with 125. To get from 999x to 1x, you're dividing by 999. So you'd have to do the same thing to this side of the equation to make sure it stays balanced. Okay, and that's going to be 125 over 999. And we cannot simplify that any further, so we'll leave that as our final answer. 125 over 999. Okay, next we've got 621, 621, 621. Can we use this that we've done here to predict what that final answer is going to be? Well, we can see that just like in part G that we've got up here in green, we have 3 repeating digits just after the decimal point, 621, 621, 621. So we would have to follow the exact same process as what we've done here. We would still have to go all the way up to 1000x, but it wouldn't be equal to 125. Instead, 1000x would be, sorry, that's 100x. 1000x would be equal to 621. Actually, that would be 1000. Sorry, once we've done 1000x, take away 1x, we'll have 999x is equal to 621. And then we're going to have to divide both sides by 999. So we get 621 over 999. This is another one of those fractions that can be simplified. So let's have a think. If it's in the 3 times table, yep, that will work. So we could divide them both by 3, and we'd get 207 over 3. Could we divide that even further? Let's have a think. 207. Well, we can divide that by 9. So if we simplify that even further, divide that by 9, 207 divided by 9 gives us 27. And then 333 divided by 9 gives us 37. So we've done that there. And that was using our previous example, because we would have had to have followed the exact same steps before we got to here. Okay. And then we've just solved for x and simplified. So that was 27 over 37. Can you do the same thing for I as well? Yes, we can. Let's just rub this out. I'm going to leave all of this here still. And what repeating digits do we have here? Well, after the decimal point, we've got 0.204204204. So this time we'd have 999x. It would go up to 1000x because we've got 3 repeating digits. And that's going to be equal to 204 once those decimal points have cancelled out. Then we're going to need to divide both by 999. So we get 204 divided by 999. How can we simplify that? Let's try dividing by 3 again. 204 divided by 3, yes, that would work. We'd get 68 over 333. And we could not simplify that any further. So that would be your final answer. That was question 1, part I, and it's 68 out of 333 for question 1I. Okay, I'm going to rub these out. For question 2, it's a very, very similar thing. They've just presented it slightly differently. In question 1, they'd written out all the repeating digits and put ... But in question 2, they've used the correct notation and they've used the symbol above the recurring digits. So that first one, 0.2 with a dot on top of it, that means 0.2222222 for infinity. Straight away though, 0.2 recurring, if you think back to 0.5 recurring, that was 5/9. 0.1 recurring, that was 1/9. So 0.2 recurring, straight away I know that's just going to be 2/9. Same thing with 0.8. Straight away I know that's going to be 8/9 because it's just 0.8 recurring. 0.18 recurring. Why don't you try and predict what that's going to be before simplifying it? Let's do that one in full. Okay, so I'm going to write out, this was C, and we've got 1x. I'm going to say that was equal to the original value, which was 0.1818. So if we multiply by 10, is that going to work? No, it's not, because we're only going to have 1.8181. When you've got 2 recurring digits, you're going to need your values to move down to placeholders. To do that, it will have to be multiplied by 100. Now we've got 18.1818. That's what we wanted. So if this was equation 1, this would be equation 3. And we're now going to do equation 3, subtract equation 1. Thinking about our x's, you've got 100x, subtract 1x. That will leave you with 99x. Then we've got 18.181818. Take away 0.181818. Your 1/8 will cancel out, and you'll just be left with 18. we now need to solve our equation for x. To do that, we're going to have to divide both sides by 99. Both of these are in the 9 times table. So you can divide them by 9 and you get 2 11ths. So that one there, 2 11ths. 0.18 is 2 11ths. Okay then, let's have a look at the next one. 0.53. We can see straight away that it's going to be a really similar thing to what we had going on in part C, because we just have 2 recurring digits straight away after the decimal. So we can actually skip straight to this point here. We know we're going to have to use 100x and take away 1x. Once we do that, we'll be left with 99x. Then we'd have 53.5353 subtract 0.5353. So we'd be left here with just 53. Now you need to solve your equation. Divide both sides by 99. And this was question 2D. Yep, and we cannot simplify that any further. So your final answer there is going to be 53 over 99, or 53 99ths. Okay, the next one, E. Very similar thing. We've got 2 digits recurring straight away after the decimal. So that 99x is going to be equal to 75. So x will be equal to 75 99ths. However, though, this time we've got values that are in the 3 times table. Yet 99 we can divide by 3. What would we get there? We'd get 33, and then 75 divided by 3. That's like having 3/4. Divide that by 3, and you get 1/4, 25%, 25. That's going to be our final answer now. We've got 25 33rds. Really similar thing here for 0.63 recurring. Because we've got 2 digits recurring straight away after the decimal point, we know that our fraction will be out of 99 initially. And it's going to be 60, well, 99x will be equal to 63. So 1x will be 63 over 99. Can we simplify that any further? Yes, we can. They're both in the 9 times tables. That means we can divide them both by 9. 63 divided by 9 leaves you with 7. 99 divided by 9 leaves you with 11. So that one there is going to be 7 11ths. Okay, this next one, I'm going to rub this out and we'll do this one in full because this is slightly different to the other questions we've seen so far in question 2. Again, you may be able to predict what's going to happen here. You can see that we now have 3 digits that are recurring. So it's 0.112. Let's start off. We'll do this one in blue now. Okay. So we write the initial value as equal to x. So that's 0.112, and that will go on for infinity. 10x, is that going to work? Let's have a look. If we move values down 1 placeholder, that's going to be 1.12121. So that doesn't work. Let's try 100x. So there we would have 11.21121. That doesn't work either. Let's try 1000x. So now the values are going to move down 3 times. So we've got 112.112.112. There we go. We've got a match. You can see here we've got the exact same values in the exact same order after our decimal point. If we label this again, this would be our first equation, second, third, this is our fourth equation. And we now need to do equation 4, subtract equation 1. Thinking about our x's first, if you've got 1000x and you take 1 away, you'll be left with 999 x's. 112 0.112, take away 0.112, you're going to be left with 112. To get from 999x to 1x, you divide by 999. You need to do the same to the other side of your equation to keep it equivalent. And can we simplify that any further? Let's have a think. So we've got this. And that's it. Yeah, we cannot divide that by 3. So that's going to be your final answer there. Cannot divide that by 9. Let's just double check that. Yeah, okay, great. That's going to be our final answer there. I'm just going to write these ones below it because we've been running out of space slightly here. So that was 1, 1, 2 over 999. Okay, see if you can predict what this one will be before we simplify it. We're going to do this one out in full. Okay. Now, because I've got 3 recurring digits, 3 recurring values, I know that all of the initial steps here are going to be the same. So I'm actually only going to rub out the right-hand side of my working here, because it's going to be a very, very similar thing here. Because we've got 3 recurring digits, they recur straight away after the decimal point. So it's going to be a very, very similar first few steps for our working out. Let's have a go then. So this one was x was equal to 0.339339 recurring. By 10, that's not going to work. 39393. 100x, that's not going to work. Let's just make doubly sure. See, they're not matching up after the decimal point. Let's try 1000x. Hopefully this is going to work for us. Got a decimal point in the same position. And then we've got 339. That's what we wanted. That's what we needed. So we're now going to do line 4, take away line 1. 1000x take away x leaves us with a 999x we've already got, and then 339.339 recurring take away 0.339 recurring will leave us with 339. So to get from 999x to 1x, you're going to need to divide that by 999. Okay, there's lots of 9s, lots of 3s here, so straight away I'm going to try dividing by 3. Will that work? Yes, 339 divided by 3 will give you 113. 999 divided by 3 will give you 333. And we cannot simplify that any further. Okay then, let's just write our answer in here. So that was 113 all over 999, and we'll do the final example out in full. By all means, predict it now, see what you're going to get, but make sure you check. I'm going to leave this part of the working out on the left-hand side the same, because it's still 3 digits straight away after the decimal place that are recurring. So it's going to follow a very, very similar structure here when we're doing our working out. Okay, 1x, we just write out the value sign, so we had 0.171 and then 171. Okay, by 10 we'd have 1.711711. So that doesn't work. 100x we'd have 17.1171. So that hasn't worked either. This should work now. Let's test it out. Move that down again. So we've got 171.171. There we go. Bingo. We got it. Okay, we now need to do line 4, take away line 1. 1000x take away 1x gives you the 999x that we've already got. We've now got 171.171171 take away 0.171171. That will leave us with 171. We now need to simplify, we now need to solve the equation. To do that, we're going to divide both sides by 999. And then we need to think about if we can simplify. Now, 999, straight away, I know that's going to be in the 3 times table. I know that's going to be in the 9 times table. Let's try and do 171 divided by 9. Let's try that. So just in my bus stop method, how many 9s go into 1? None. How many go into 17? Well, 1 with a remainder of 8. How many go into 81? Bingo, 9. So if we divide them both by 9, we will get 19 over 999 divided by 9, 111. Okay, so that was our final answer there. We have 19 over 111. Okay, that's the end of lesson 2 today. I strongly recommend, if you found this challenging, having a look at those Heggerty videos and trying the Heggerty tasks. If you're one of those people that got the hang of this and found it quite simple, then I particularly recommend you have a look at task number 54, because task number 54 and the video there, they have an additional example of a different type of recurring decimal that we haven't included in this lesson, but it would be great for you if you wanted to extend yourself further. As always, the Corbett Maths, if you just type in, go on to Corbett Maths textbook exercises, Control F, recurring decimals to fractions, you can find it, or you can go by the numbers. That would be video number 96. Have a go at the textbook exercise, try some of the practice questions, and if you have any questions, just message me. Okay, see you in the next lesson, everyone.